Pika. I'm Ya-wen, or Vivian, and he's Moven. And we are going to talk about Mopro to make mobile client-side proving easy. So we found that there are more and more mobile users than compared to desktop users because of the accessibility and portability of mobile. And then there are many powerful features in native mobile. For example, the performance is better than browser, and it can access to hardware devices like camera, GPS, biometrics, and also the offline functionality and push notifications are also interesting features in native mobile. And last but not least, the mobile development lacks infrastructure for ZK applications. So our goal of Mopro is to improve the mobile developer experience. So we provide FFI, CLI, and provide templates and documentations. And we want to improve the native mobile performance to generate like ZK proof and cryptography proofs. And also we want to build a mobile development ecosystem as complete as the web app ecosystem. So we want to build packages for mobile developers and also build good communities for those who want to build mobile apps. Yeah, so our roadmap is to integrate as more as adapters as possible. For example, ZK and Hello 2 and folding system and PCFFG in the future. And we will generate the bindings for different platforms, not only iOS, Android, but also for website and gamings and also your desktops. Yeah, so we can look detail in this structure. We are now in the middleware of the Mopro is in the middleware, but we need to coordinate the backend, the proving system, GPU acceleration, and the front end is the like SDK for different protocols. Yeah, so how to use Mopro? We provide a CLI for developers to easily use Mopro Init, Mopro Build, Mopro Create to create a iOS or Android templates, and then you can easily getting started with the app. So the benchmark on mobile, it can be speed up to like 6 times faster than Snark.js on the Mac, but the disadvantage of mobile is that the memory is really few. So we need to solve this problem. And this is the benchmark of CPU, and we will introduce the GPU research results.
Okay, so we've been researching on GPU acceleration on client-side proving for a while, and what we found is that client-side proving is a completely different story from server-side GPU. So we want to highlight 2 things. The first is scalability. So if you look at the right-hand side table, you can see that although there are like 9x, 10x on compute power or memory capacity of server-side GPU, it seems not that much, but the point is it can be clustered hundreds of thousands of GPU to do extremely fast computations. So on the other hand, the mobile GPU is just the one sits on your phone, so it's relatively limited. And the second thing we want to say is that the ecosystem support of the shading language, which is where we do programming on GPU, is really different. So CUDA is one of the most mature GPU shading ecosystem right now. So if you want to do development on CUDA, it's much more easier than Metal, which is the one we do GPU acceleration on your iPhone. Yeah. So we target MSM to accelerate because it encompasses 70% of the proving time in like gross 16. So the first thing is that we found that current CPU implementation is much more faster than GPU1 in the Z-Prize 2023 winners. And the second thing is that although the GPU is much more slower in this case, but when the instance size grows, the GPU has the potential to shine in larger instance size. Yeah. So few takeaways is that we still have so many things to under exploration. So better elliptic curve library or making much more memory efficient for mobile. And we also want to leverage all of the computing resource on mobile device and make sure the GPU and CPU synchronize in a way that maximize the computation speed. Yeah, so GPU is a totally different story, and we want to explore more.
Yeah, so here's the link to the Mopro resources, and it includes a Google form that we want to collect feedback from ZK projects, so what you need for Mopro. And there's also a GitHub link and Telegram link. Yeah, feel free to scan this QR code. Yeah, so Kopunka.
Kopunka.
Thank you, Moven and Ya-wen. Any questions? Oh, there's one over there. You guys want to give it a go?
Really? I don't think I can. Oh. Thank you.
Hello. Okay. So I saw your benchmarks. So are the benchmarks comparing the SnarkJS on a browser or against Rapid Snarks on like mobile device? Like what's your performance versus Rapid Snarks on mobile and Gnark on mobile?
Yeah, so the SnarkJS on Mac is with CLI. So I use like npx snark full proof to generate the proof. And then the Mac is M1 Pro Max. And my iPhone is the native app. So it is iPhone 12. Yeah.
Is the native app using SnarkJS or Rapid Snark?
No. With Mopro. So it's the native bindings.
Okay.
Yeah, like yeah. So we use Rust and then generate the bindings, binaries for iOS, and then we calculate the proof with the binaries.
So do you need any specific DSL that you have to write your proofs, or like circoms, or like you're going to integrate other DSLs as well?
So actually we use the circom results, the Z-key and Watson, and then you can use these two things in Mopro, and then it will generate the native bindings for you to generate the proofs, and then you can use it in the native app. And then for example, the iOS, and then it will create also a FFI for Swift. So I can call like generate circum proof in Swift to generate this proof. Thank you.
Any other questions? Oh, there's one over there.
Oh, sounds nice. I just wonder about any like attempt or challenge for building like AVX specified instructions, because when it comes to like, looking at the vector databases in Ethereum fields, they're trying to facilitate its calculation by implementing those some transformer calculation to embed it into the CPU with using AVX instructions. Are there any like attempt to doing similar approaches when it comes to doing electric curve acceleration for ZK stuff or kind of things?
Okay. So can you say it again?
Okay, so I just know about there's some attempt to accelerate some dot product calculation or like matrix calculation when it comes to using a transformer architecture for accelerating each calculation using AVX instructions, which is to accelerate on the CPU compiler, which is compatible with x86 architecture. So some vector databases try to use those like AVX instructions to make sure to optimize those instructions. So when I just try to looking at those approaches, I think it could be applied to accelerate on the calculation for electric curve, because we can just unloop those duplicate calculations into compiler level. That's my kind of imagination, but have you ever tried those temporal kind of things? That's my question.
Yeah, it sounds interesting, but we haven't tried that, like implementation that, and welcome. Maybe you can create an issue in our GitHub, or we can contact each other, and then know much more details about your suggestions. Yeah, thank you.
Oh, we have 2 questions. Oh, maybe the front row first.
Hi. Here. Is your research concerning also storage on mobile, or it has nothing to do with that?
Yeah. Also the storage and memory also really filled in mobile.
Okay.
Yeah.
So and yes, with this, are you using like a different key generation for every time I want to prove something or a change is made? Because I think that this adds more to this phone storage, right? I heard from the folks of Nord that they have like a different backend that only needs one key to generate and store.
Yeah. So now when we explore the second prover, and then there's a really large Z key if your circuit is really big. So yeah, it sometimes takes like several gigabytes to store in the storage, and it's pretty big. But yeah, like the Noir example, it has really smaller Z key, and it's better for client-side proving. So maybe in the future we can integrate more proving systems that is better for client-side proving. Yeah, thank you for your suggestion.
And also on the GPU side, we're trying to use a much more efficient way to encode the elliptic curve points and scalars to make sure it is much more, efficient for the storage on the mobile device.
Thank you.
Okay. Nice to meet you. I want to ask a question about the device memory limit. Some more detail about your benchmark. As we know, the more larger your circuit or app was, then the more device memory it may take on the GPU or your mobile memory. So, for example, you have shown that you can do KCAC or SHA-HASI on your circuit to generate the proof. But I want to know for your device benchmark, 8 GB memory, how large you can do in SHA or KCAC?
So for
example,
I know.
you use Snap.js and your Rust binding to prove on your mobile use matter, and the app do SHA-HASI about 1 KB or 1 million byte data as the prime image. But
actually, for like SHA or Ketchup, it doesn't take like that much memory to generate proof in mobile. So I would say like maybe less than 1 gigabyte, but I forget the exact number.
Okay.
Yeah.
Okay, I got it. Just want to know the limit.
But yeah, like RSA is much more than like Ketchup or SHA.
Okay.
Hash.
Oh, there's one more question there. See, everybody's interested in mobile application.
When you say mobile is not clusterable, like it has to be standalone, I'm just curious. Have you like looked into, like there was like Boeing or like there's like, I guess a few software or like a few frameworks that can actually facilitate cluster computing, or even like building a, I guess what they call like a cluster, distributed cluster just with mobile devices. Have you considered like looking into those, and so that to just like get around the so like memory limit or like storage limit of a single device? Thanks.
Yeah, I think there would be a way we want to explore, but we want to start from much more simple stuff, which is doing the proving on your own device, and then we do the method you propose, like leveraging many others like consumer device to do so. Yeah. But it still cannot be compared to the server-side GPU when like the one in data center is like hundreds of them inside. It's really a really big difference. So when you look at the benchmark of GPU acceleration, you might you need to be mindful about like which device they use to benchmark. It's really different.
Okay, thank you everyone. Let's